Okay, so do we have any question with the syllabus for the guy online? Do you have any questions? Okay, let me answer the question here. In this class, we focus on the Python. No, we focus on pseudocode. We focus on Raptor and Python. So basically, for this class, we use three types of the coding here. Pseudocode actually it is not the coding, but it is a simulation only. The Raptor also it is simulation. And for the coding, we work with some of the assignment. We work with the Python, but not all of them. Some of the assignment you work with pseudocode. Some of assignment you work with Raptor, not always Python. Okay, so I believe that you have no question for the syllabus. Let me move to the announcement here. Yes, in the announcement we have some thing which I want to highlight here. We have information about the Zoom meeting for you guys join class from the Zoom meeting. Right? Also, this class is linked to the Cengate. Right? This class is linked to the Cengate, and when you go to the module, when you scroll it down, you have start here to access to the Cengate my tab here. So in the case you want to work with a homework assignment, or you want to read, you want to work with reading, you can go to the Cengate here. So when you go to the Cengate, oh, I think I set it for the student. That's why I'm not able to go to the Cengate. So in the case you log into the Cengate, okay. So in the case you log into the Cengate, you see they also break it down with the unit here, right? And you for each of the unit also you have the sum of the assignment also. So if you have any problem with the Cengate, think about you are not able to accept the specific assignment, you should escalate it to Cengate, not to me. So whenever you escalate it to Cengate, try to put my email in the ticket also, so I have idea what's going on with that. Okay. So if you for anything, if you want to escalate it to the Cengate, you have the announcement here. You go with the problem with the my tab, you go with the module, you go with the problem with the my tab, and you raise the ticket from there. Okay, now let me move to another announcement. We have some other one. Discussion. So basically, if you go to the module, for each week we will have at least one discussion. Right. So basically, you think about this one here. For the module one, we have two discussions here. Remember, for every discussion, you have two debates for every discussion. The first one is on Thursday, and the second one is on Sunday. So the Thursday is initial post. You are supposed that you have to post the initial post before no later than Thursday. And after you post the initial post, you have to make sure you follow up to reply at least to other students. And the other due date it is on Sunday. Right? So make sure that in the canvas, I'm only able to set the due date for the initial post only. Right? But make sure that when you're done with the initial post, you have to follow up and you have to reply at least to other students, and the due date is on Sunday. Now, we have for this class, we work a lot of assignment. We have to work with Raptor. The Raptor is a simulation for the coding. So in order to work with Raptor, you are required to install Raptor on your computer. So make sure that when you work with Raptor, you have to download the. You have to download What? Yeah, you have to download. Why this one is? There's something wrong with this announcement. Let me check it again. So now let me show you how to work with the adapter here. Oh, we have a shame for this one. Let me check it again. Okay, so right here. Okay, sorry. How's this one? Now let it go with the first one. Okay. So for this class, you are required to install Raptor in order to work with many assignments, and you have to work with a final exam and a final project with Raptor. So in order to install Raptor, you go to the website here. You go to the website Raptor here, download the tutorial. You go to the website, and you have to make sure that you download the portable version. So even that you work with the Mac or Chromebooks, it's okay. You have, in the case you work with the Mac computer or Chromebook, you can download it to the USB drive, and you run it from the USB. It's okay. So for this one, you have, so in order to download. Okay, so you go to the website here. You go to this website. This one. Right, so see, this is the way you download the Raptor. So when we scroll it down, they have many versions. They have many versions for the Raptor, but for this class, make sure that you have to download the correct version. And it is a portable version here, this one. It has the portable version, and you click the download. This one. So you see, it's already downloaded, and you can run it from the USB driver or whatever you want. Right, so see, this one, that is the interface work with it. Download from here. I run the portable version. Now that is the interface of the Raptor. Okay, so now, well, guys, you are here. You just make sure you download it and install the computer. And for the guys online, so make sure that you download it and install on your computer. So let me share the the link here. Here's the link to download the Raptor, right? And you go to the link, go to the website. When you scroll it down all over the way, you make sure that you go to the portable version and download the portable version. Okay, so make sure that you have to install it before we come with some of the hands-on activity for today. This is Raptor. And it's free, yes.
I just log in. It said like it was locked.
Okay, what is your username? And the, oh, it's white now. Okay. Password 01 exclamation. P in capital. Heaven, right? Okay, so I give you 5 minutes to make sure that you download and install the router with your computer. What? Oh, I hear. Can you come here? Show me what is your name. Which one are you? This one? This one? Okay, can check now. Yes. Okay, so everyone already download and install it. Okay. If you do not have any questions, let me move to the lecture here. So for the chapter 1, it's an overview of the computer and programming. So in this chapter, you will learn about the computer system, simple programming logic, step to involve in the programming development cycle, pseudocode statement, and flowchart symbol. Using the Sentinel value to enter program, programming and user environment, and evolution of programming mode. Now, your understanding about the computer system. Computer system is a combination of all the components required to process and store the data using a computer. So for the computer, you have hardware. That hardware is everything about the physical equipment associated with the computer. You can think about, you have the CPU, right? You have about the motherboard. Anything is a physical. You can see it's a physical here. And beside from the physical, you have beside from the hardware, also we have the software. Software is everything on top of the physical. You can think about operating system, everything about the application here, right? So the computer instruction that tells the hardware what to do. That is it tells the hardware what to do, and you can have the program. It's instruction written by the programmer. Think about this one. You are the one who do the coding. You tell the computer what to do with the program. Right? And you have the programming. It is a way you writing the software instruction to tell computer what you want to do. And the computer and hardware and software, they have to accomplish 3 major operations. You have input. Right? So in order to tell the computer to process something, you need to get the input to the computer. Right? Think about here. You need to write the program. Think about you need to code for program to find out what is the area of a rectangle. Right? What is the area of rectangle here? So in order to find out what is the area of rectangle, what do you need? What do you think? What do you need here? In order to find out area of the rectangle, of a rectangle, what do you need? Yeah, you need the length and you need the width, right? You need the length and you need a width here. The same when you write the coding also, you have the input. That means you have to bring the data into the program. You have to tell what is the length here, what is the width here, right? That is the first process in every operation. The second thing is that when you record the input, the second thing is that you have to do with the processing here. Yeah. So when you got the input, program got the input, it do everything with the processing. Think about in the case, find out what is the area of the rectangle. You just time it together. Right? You time the length and the width. You got the area. You got the area of the rectangle. And the last thing is that once you already find out what is the length, what is the area of the rectangle, you want to print it out. You want to print it out either on the screen or you print it out to the paper, and that is the process of the output here. So basically, for every program, for every computer and hardware, software, they have the three major operations. Input, you get the data, into the program, right? You have processing. When you got the sufficient input, you do everything is the processing. And when you're done with the processing, it's the time to take it out from the program, right? From the program here. So the same when you work with the adapter here. Let me show you the very simple program here. So in the case you work with the adapter, that is the interface adapter. That is the interface adapter here. And if you look on the adapter also, they have some very basic function with the adapter here. The adapter is a simulation program. Coding is not the real programming language. Right? It's only for the simulation only. So in the adapter, you see, you have the input here. You see, that is input. Right? You got the input. Think about you ask user enter the length, enters length. You ask user enter width. So when you got the length and width, you do everything with the processing. In the adapter, processing is everything you do with assignment here. That is the processing. You do everything with the assignment in the adapter. And now you've done everything with the assignment in the adapter. The last step, you have to make sure you print it out. What is the area of the rectangle? Right? So in that case, if you want to do it, print it out, you use the output here. Okay. Now you can follow me with the adapter here when you write very simple program here. When you write very simple program. So this program you want to find out what is the area of a rectangle, right? You want to find out what the area of a rectangle, and you know for sure that in order to find out what is the area of a rectangle, you need the length and you need the width here, right? So for that one, you need two inputs. It is their length and their width, right? So the first step, you have to set the program here. I think about here, the rectangle here. Right? Now for this one, when you do, let me do it again. Right? The first step, you need to get the input here. You need two input for this program. Right? That's why I do it right here. Or I can do it later. So when you do the input, you right click, you go to the edit. Right? So for every program, for every input, you have the two parts here. The first one is the prompt. Prompt that you tell the user what he have to do. Right? You have to make it to tell user to do. Right? Details and the length. And that is a prompt. That's a prompt. Tell user what they have to do here. And in the prompt, now so when you have the prompt, you have stored into the variable name. In that case, you store in variable name. It's a length here. It doesn't matter. The variable name doesn't matter. But make sure that when you work with the programming, try to make the variable name meaningful. So in that case, instead of using X or Y, it should be more clarified. should be more specific. You tell that is the length here. Alright, so that is a step you got input for the length of the rectangle. And you can do the same. You know that in order to find out area of the rectangle, you need both of the length and width here. Now, on this one, I can copy it and I can do it one more time with this one. I modify it with width and I change it. Okay, so now I'm done with the input processing. Sorry, I'm done with the input process. Right? I already got the length and I got the width from the user. Now, the second step for every program is the processing. It's the processing here. So in the case of the Raptor, everything with processing, you work with the assignment here. So I can drag and drop the assignment. Drag and drop the assignment. Right? So in the assignment, I set what? I set area. To what? To length, time, width. Okay, so that is the processing. You see, everything here, if you look on the process of this program, if you look in the process of this program here, everything here, they are input. Right? This one, processing. Now, the last step, you have to take it out and print it out. What's the area here, right? So, in the case you work with the Raptor, in order you want to do the output, you have the output here. You drag and drop the output, and in that one, I make it with the from here, the area. The rectangle. Yeah, that is the program. So this is very, very simple program with this one here. Now you see you have the three major part here, and this is the output. Okay, that's the output here. Okay, so now you do everything with the with this program, right? You got the input, you do the processing, and you got the output. Now the last step, you want to run it. So basically, in the Raptor, you have many ways to run it. You have many ways to run it. You have the option here. You see, you have the option for run it here. Right? The first that is one option to run it here. So when you run it, click on this one here. See, you go with the first one. It's a prompt to tell you what you have to do here. So think about I enter the number 20 here. Number 20 here. So what happened? What happened here? You see, when I enter the number 20 here, you can see what happened here. When I enter the number 20 for this one, actually the value of number 20 will be stored into the value of variable name length here. Sorry. It's stored in the variable length here. That's why you see for the variable length you have number 20 for this one here. Now I can do it again. I can do it again for the other one here. Now width here, I enter the number 10 here. So what happened? You see, after I put the number 10 here, is the width here, right? It assigns number 10 to the variable length. Sorry, to the variable name width, and I find out what's the area. Area is the length. What is the length here? You can see for this one. Length here, it takes it out the value 20 from the variable here, right? And the width here, it takes it out value of 10 from the variable name width here. And you just multiply them together. You have 200 here, and after that, you assign the value of the 200 to the variable name area here. So see, after the processing process here, I got the area of 200 here. Now the last step, I need to take it out. I need to print it out on the screen. It is the area of the rectangle here. So that's why this one here is a prompt, and it take it out the value of area. What's the value of area? Value of area here is a 200, and it prints out 200 here. Okay, it's very, very simple program is this one. Now that is the first way you run the Raptor. It's the first way you run the Raptor. Now in the case that you want to follow it step by step, in the case you want to do the follow step by step, think about when you want to do that. You have very complicated program. You have very complicated program, and you want to chase it down step by step. So in that case, you can run with this one here. See, you have the option here. This option here. You have this option. This one is run by step only. That's very helpful in the case you want to debug to see what's going on with your program here. So now see, when you run with this one here, what happened here? I click the first one, I go to the next one, I go to the next one. It tells you enter the land. So I put again. This time I put a 40 here, not 20 anymore. So see, after this one, after I got the 40 for this one, it assigns the value 40 to variable name land here. Right? Now I run it again, one more step. I run it again, one more step. I wait here, I put the 20 here. All right. So I have the 20 for this one. I run it again. After the processing, you have the 800 here, and the last one. Is the last one. I have the 800 is area of the program. So that is very helpful in the case you work with the step by step. In the case you want to chase down what's wrong with the program, or you want to debug here. And another way you can run the program here. Another way you can run the program. You can run it by you go to the run and you run with the compile here. It works very fast. It works very fast here. Yeah, 200 and 10 here, and work very fast. And after that, you have to make sure you go to check for the output here. You got into 200 here. Okay, it's very simple program. But anyway, I want you to understand about the processing of the input, about the processing and output here. Any question? Okay. So now we go back to the lecture here. So for every program, basically you have the three major operations. You got the input, you got the data from end user, or you can get it from anything. You can get it from the file, whatever it is. You do when you got the input, you do everything is the processing, and when you done with processing, you need to take it out. You need to print it out. What's the output here? Now, component of a computer, you have the central processing unit, the CPU. Think about it's the brain of the computer. Do everything with the processing here, calculation, multiplication, whatever it is. And you have internal memory. You have RAM and you have ROM. RAM is a random access memory. That means it loads the program in the RAM, but whenever you reload it, everything gone. Right? And the ROM is a read-only memory. You have mass storage device. You can think about you have hard disk drive or SSD nowadays. Right? Also nowadays you can store it on the cloud. Also you can store the program. You can store the data in the Google Drive or Dropbox, whatever. Right? Okay, and you have the system unit. It is how for the CPU, internal memory, and most of the mass storage. And input device, you can think about we have the keyboard, you have the mouse, they are the key, they are the input device, and the output device, you have the screen here, or you have the printer, they are the output device. Okay, now we go with the central processing unit. It's a CPU, it is a core, it's the brain of the computer. It receives the program instruction, perform arithmetic and logical operation, and control as a computer component. You think about it's a brain of computer. Everything it do everything with the calculation here, processing here. It consists of millions of the transistors on a single microchip that plug into the motherboard, and the speed of the CPU is measured in the gigahertz. Gigahertz, you can think about hertz is a fluctuation here. So if you have 1 hertz, you have what is it? You have 1 cycle of the fluctuation. But gigahertz, you have the billion of the fluctuation. And you have internal memory. You have the RAM and ROM. ROM is the read-only memory. It contains instruction used by computer during startup, and you can think about it's a reference chip, and you cannot be altered by the computer user. The RAM is the most common here. You see, it is a scratch pad for the user as he or she work. it can be read from on and written tool, and it's measured in the megabyte or gigabyte. This class is not focused on the hardware, so I just skip it. I just do it very fast with the hardware. Okay. Oh, now you have the basic unit of memory. You have the bit. That means for each of the bit you only have the two values, 0 and 1. It's a binary system, 0 and 1. Right? And for the byte that means you have 8 bits of them. You group them together, and so on. You can have the kilobyte and megabyte and gigabyte and so on. And have the mass storage gigabyte. You can think about SDEV, or you can have optical storage. You have SSD nowadays. It's very, very common. Also nowadays, cloud computing and so right? You do not have to store everything on your on your personal computer, but you can store on the cloud also. For the input and the output, you see input everything you got it from the user, right? It can be the keyboard, mouse, digital pen, modem, or wireless internet connection, touch screen, anything. Output, you can have the monitor, printer, speaker. Now you have the definition of the software, and the software to break it down in the two groups of the software. The first one is application software. Application software enhance the productivity, solve problem, supplies information, provide entertainment, and you can think about everything about the application software that you can see nowadays, like Microsoft Office or whatever it is, Photoshop or Lightroom. They are application software. The second one is a system software. System software is the one who control and maintain the hardware. And the most common is the operating system. You can think about Windows or Mac here, right? That is the one who control about the hardware. It interface with the end user, here, and manage and communicate with application. You can think about Windows, DOS, Linux, or Unix here. Now you have definition about a programming and scripting language. You break it down into some of the major groups. The first one is the machine language. Machine language, everything consists only sequence of 0 and 1. And actually, every computer ultimately only work with 0 and 1, right? Because it only work with the binary system. You have million of switches in your computer, and for it, you can think about the switch. Oh, where am I? You can think about in the computer, you have million of the switches here. Right? So whenever you switch on, you have bit number 1, right? And you have the bit, and have a switch off, you have bit number 0. That's why ultimately for every computer, you only work with 0 and 1 for a computer. Right? So for the low-level language here, you have the machine language. It consists of only sequence of 0 and 1. Think about this one. You see when you see for the input or processing, you see everything in 0 and 1. It's very hard for you to understand it. It's very hard for you to understand it. That's why they come up with one more step here. They come up with one more step about assembly language. It is a group. They group some of the bits together, and they simply represent the machine language. Think about you add A and B, so we have add A and B here. But still, it's very hard for you to understand with the assembly language. Now we move to the high-level language. High-level language is contain English word and phrase and algebra expression here. It's easier for you to understand it. It's easier for you to learn and use, and the resulting program are easier for you to read and modify it. Some of the example of the high-level language, you have the C++, JavaScript, Python, Java. These were basic, whatever here. Now, so you think about you have the low-level language, and you have the high-level language here. What are the pros and cons of low-level and high-level language? What do you think? What are pros and cons of low-level? If you think about the low-level here, what are the pros? What are the pros and cons of low-level? Now think about the low-level first. What are the pro and con? What do you think? What are pro and con of the low level here? Yes.
I would say a con is that it's pretty complicated.
Yes. Yeah, complicated for the con. It's very hard for you to understand. Yes.
I say for pro that assembly language probably takes less time to interpret for the computer.
Yeah, right. The thing is that, yeah, because it works exactly with the hardware here, right? You work directly with the hardware. You do not have to translate it. You do not have to interpret it into the machine language, right? So you directly work with the hardware. Yeah. Anything else? Anything else? So what happened here when you work directly with the hardware? What happened if you work specifically with one computer and you move to the another one? What happened? It might be not compatible, right? The hardware is not always the same. Right? That's why when you work with a low level here, it is a hardware specific. So think about it might work with one computer, but when you move to another one, it not work. Right? Yes, that is something about pro and con of the low level, and of course a high level. You have pro. It's very easy for you to understand using English and phrase here. But of course, you have the con. You have to translate it. You have to interpret it into the machine language here, because you see, ultimately, in order to do processing with program, computer have to work with the machine language. Yes, of course. Yes, very good answer. Now, understanding about the computer system, the programming language, it is used to write the computer instruction. Code is the programming code, and writing instruction is called the coding the program. That's what they want to learn it here. Some of the example is the Visual Basic, C++, C#, and Java or Python here. Also, we have definition about syntax. Syntax is the rule governing the word usage and punctuation. And mistake in the language, it is a syntax error. So that's why you need to debug it to find out what is wrong with your program. Now you have the definition about the compiler and interpreter here. So I think this is a very short video. Last one.
Computer what to do in order to come up with a solution to a particular problem. Programs are written using a programming language. A programming language is a formal language designed to communicate instructions to a computer. There are two major types of programming languages, low-level languages and high-level languages. Low-level languages are referred to as low because they are very close to how different hardware elements of a computer actually communicate with each other. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages, machine language and assembly language. Machine language, or machine code, is the only language that is directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are written as a string of ones and zeros. A program instruction in machine language may look something like this. Technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly languages come in. An assembly language is the first step to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. A translator is required to translate the assembly language to machine language. This translator program is called the assembler. It can be called the second-generation language since it no longer uses ones and zeros to write instructions, but terms like move, add, sub, and end. Many of the earliest computer programs were written in assembly languages. Most programmers today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications, which use very precise timing or optimization of computer resources. While easier than machine code, assembly languages are still pretty difficult to understand. This is why high-level languages have been developed. A high-level language is a programming language that uses English and mathematical symbols, like plus, minus, percent, and many others, in its instructions. When using the term programming languages, most people are actually referring to high-level languages. High-level languages are the languages most often used by programmers to write programs. Examples of high-level languages are C++, Fortran, Java, and Python. To get a flavor of what a high-level language actually looks like, consider an ATM machine where someone wants to make a withdrawal of $100. This amount needs to be compared to the account balance to make sure there are enough funds. The instruction in a high-level computer language would look something like this. X equals 100. If balance less than X, print insufficient balance, else, print please take your money. This is not exactly how real people communicate, but it is much easier to follow than a series of ones and zeros in binary code. There are a number of advantages to high-level languages. The first advantage is that high-level languages are much closer to the logic of a human language. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program. Learning a high-level language is not unlike learning another human language. You need to learn vocabulary and grammar so you can make sentences. To learn a programming language, you need to learn commands, syntax, and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Both machine code and assembly languages are hardware-specific and not portable. This means that the machine code used to run a program on one specific computer needs to be modified to run on another computer. Portable code in a high-level language can run on multiple computer systems without modification. However, modifications to code in high-level languages may be necessary because of the operating system. For example, programs written for Windows typically don't run on a Mac. A high-level language cannot be understood directly by a computer, and it needs to be translated into machine code. There are two ways to do this, and they are related to how the program is executed. A high-level language can be compiled or interpreted. A compiler is a computer program that translates a program written in a high-level language to the machine language of a computer. The high-level program is referred to as the source code. A typical computer program processes some type of input data to produce output data. The compiler is used to translate source code into machine code or compiled code. This does not yet use any of the input data. When the compiled code is executed, referred to as running the program processes the input data to produce the desired output. When using a compiler, the entire source code needs to be compiled before the program can be executed. The resulting machine code is typically a compiled file, such as a file with an exe extension. Once you have a compiled file, you can run the program over and over again without having to compile it again. If you have multiple inputs that require processing, you run the compiled code as many times as needed. An interpreter is a computer program that simulates a computer that understands a high-level language. This means that the interpreter translates the source code line by line during execution. Consider again a computer program that processes some type of input data to produce output data. The interpreter executes the code line by line, which results in the desired output data. The only result is the output data. There is no compiled code. When using an interpreter, every time you want to run the program, you need to interpret the code again, line by line. There is no compiled code to use if you have multiple inputs that require processing. To understand the difference between compiling and interpreting, let's examine the equivalent in human languages. For example, consider a movie made in Asia where all the characters speak Vietnamese. To market the movie to an international audience, the spoken text needs to be translated into English. A translator would sit down and carefully translate all the text and create subtitles for the movie. Anytime someone wants to watch the movie, they can turn on the subtitles. This type of translation is the equivalent of compiling. Everything is translated once and can be used many times afterwards. Now consider a delegate from Vietnam giving a speech in the United Nations in Vietnamese. In order for the attendees to understand the speech, there are a number of translators who provide a translation that is transmitted to the attendees' headphones. This translation occurs close to real time. Every time the delegate speaks in Vietnamese, the translators get to work. This type of translation is the equivalent of interpreting. Text is translated line by line as necessary, and the results are not used again. Compiled code tends to be faster since the translation is completed in one step prior to the actual execution. Interpreted code, on the other hand, is more flexible and can be run interactively. For example, using interpreted code, you can try out a few lines of code to see if they work very quickly without having to go through the steps of compiling and executing the program. One advantage of using compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner workings. When you install a software application on your computer, you are typically installing a compiled version of the code. You can run the software application, but you can't open up the source code in the original programming language. For many companies selling software applications, the original source code is a well-kept secret and gives them their competitive advantage over other companies. Examples of compiled languages include C and its derivatives, C++ and C#, COBOL, and Fortran. Examples of interpreted languages are Java, Perl, Python, and Ruby. There are two major types of programming languages: low-level languages and high-level languages. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages: machine language and assembly language. Machine language, or machine code, consists of binary code and is the only language that is directly understood by the computer. An assembly language consists of a set of symbols and letters and requires translation to machine language. Both machine code and assembly languages are hardware-specific. A high-level language is a programming language that uses English and mathematical symbols in its instructions. To execute a program in a high-level language, it can be compiled or interpreted. A compiler translates the entire program written in a high-level language to a machine language prior to execution. An interpreter translates a program line by line during execution.
Good video, right? Bye. Okay, so we have some about understanding a simple programming logic. Programming, the syntax error cannot be executed. So whenever you have the syntax error, the program cannot be executed. And you have the logical error. Logical error is the error in program. It runs smoothly, but the output is not what we expected, right? And it's the logic of a computer program is the sequence of specific instruction in the specific order. The variable is the name, memory, location, also value can vary. The variable is interchangeable here, right? So if you go back to the, and then if you go back to the Raptor program. If you go back to the Raptor program here, what do you think? How many variables you have for this program? How many variables are there for this program? Three, right? You have the length, you have width, and you have area, and they are changeable, right? So it depends on how many you enter here. So if you enter 20 and 10, area you have 200. But if you enter the 40 and 20, the area is 800. They are changeable. They are changeable, right? Now, if you look on this program again, we can simulate what is a syntax error and what is the logic error here. Now, the thing about the syntax errors. I just modify this one here. I modify this one. I change it to the length here. So when I run it again, I have the 20 for this one. I have the 10 for this one. For this one, see, the program it cannot be executed, right? It cannot be executed, and it got stopped here because it has a syntax error. And the syntax error here because it doesn't understand what is the language here. Right? Think about this one here. If you look. If you go back to the program here again, where am I? Oh. So if you come back to this program here, okay, right? You have the one variable length, you have another variable is width here, right? So if you enter the number 20 here and you enter the number 10 here, right? So now after that one, you assign the value area to the length and width. So what is it? Width, you can take it out from 10 here. But length here have no way. You have no value here. That's why you have the syntax error for this one. And whenever program has a syntax error, program will stop and it cannot be executed until you have to correct it. You are the one who correct it here. So that is the example of the syntax error. Now let me modify it again. Let me modify it again. Change it back to the length here. Now, So I modify this one. So instead area is the length time width, I modify it to the length plus width here. This is a logic error. The logic error, so when program has a logic error, it runs smoothly. It is used smoothly, but the output is not what you expected here, right? So what do you think if I enter the length here, if I enter length here the 20 and the width here is the 10. So what's the area for this program? What is the area for this program? 30, right? You just add them together, and the area here you have the 30. It's not what you expected. Right? If you expect that, if you have the length and width, you expect that it's the 200 here, not the 30. Right? So this is an example of the logic error. So remember the syntax error, program stop until you find it out and fix it. Right? But the logic error, it runs smoothly, but the output is not what you expected. Okay, so you can see if you look on this program, you run it again. When you run it again, I have the 20 here, and I have the 10 here. You see, the area of the rectangle here is 30, it's not what you expected. Now, okay, so also we come with the definition of the variable. The variable is something it is changeable. It's changeable, right? It's changeable, and its name. The name is reference to the location of memory. Think about that one here. In the program, you have the assignment X. It's a 20 here. So what happened here? Actually, in that process, the computer reserve one slot in the memory, right? And the name of the slot here is X. So whenever we put the number 20, it point out the 20 here. We take it out the number 20 from the slot memory with the name of X here. Right? So now think of what happened here. If I have a program here, I have X equal to 20. Right? And I have X equal to 40 here. And I want to I set Y equal to X plus X here. So what do you think? What is the value of Y after the all three steps here? What's the value of Y?
60.
What do you think?
60.
No.
80.
Yes, 80. The thing is that you see, the name here it is changeable and variable. And whenever you got the new value, it will override the old value. I think about this one here. You have X20, that means you have memory. You have a slot in memory with the reference name is X here, right? So now if you put the 20, it's okay. 30 here for the first step. Now the second step, you put the X into 40. So actually this one here, this value here, it override the new, the old one here. Right? So we store the number 40 on this one here. Now, the last step, you have Y equal to X. What's it? It refers to the memory slot. Take it out 40 here. Right? And again, it refers to the memory slot. Take it out 40 here. And you have the 80 for this one. Right? So that is the definition of the variable. You have to remember that it is changeable. It always refers to the slot in the memory. And whenever you got the new value, it can override the old value. Okay? Now, we have understanding about the programming development cycle. So basically, for programming development cycle, they have many definitions, but basically they have some of the major plan here. Major points here. The first one, you have to understand the problem, and the second one, you plan the logic. The third one, you code the program, and you use the software. It can be compiler or interpreter to translate the program into the machine language. And you have to test program, and you have to put program into the production, and after that you have to maintain program. So whatever program it is, they have to include some of the major points for this one here. So you can think about the understanding problem. Think about you can think about that very simple program here to find it out, right? To find out what's the area of the rectangle. So you have to do everything with the understanding problem. Is it program here? You have to find out what is the area of the rectangle, and you have to find out. In order to find out area of the rectangle, you need to find out, you need to get input from user, what is the length, what's the input, right? And also, when you got the length and input, you do with code program that you have to find out in order to find out the area, user touch them together and time them together here, right? Now, you can use the software, think about this one, you can use Raptor or Python, whatever, you translate it into the program here. Now, after that, you have to make sure it works as expected here, right? Make sure that you enter the number 20 and 10, the expected area is the 200 here, not 30. That is very important step. That's why every program you have to make sure you have to test the program. You have to write out, you have to list all of the testing scenario in order to make sure program work as you expected here. Now you have to put it into production, right, for the sale, and after that you got the feedback from the customer, from end user. You have to keep going to modify it here. That's why they call it the life cycle here. It's a call, it's a cycle. Sorry, they call it is a cycle. Cycle that means at any time you can go back. You can go back to modify it to change it in your program. So you see, the first step, you understand program. What is it? You make a plan. What you need to do. What is the input? What's the output? And what you need to do with every processing here. Now you convert it. The planning logic you can do with the pseudocode, or you can do with the flowchart. You learn it later on this class. So when you got the pseudocode or when you got the flowchart, you can convert it into the real programming language. It can be Python or C or C++, whatever, right? You translate into the code. So you run program, you make sure it is expected what you want here, right? And you put the program into the production. And after that, you have to keep maintaining it. If you got any feedback from customer, from end user, you have to go back to modify it and to update it here. Now, understanding program is one of the more difficult aspects of program. User or end user can think about whenever I have program, it can be the user or end user here. It's the one people from whom the program is written for, right? And also have a documentation. It all is supporting paperwork for programming. You can have you have the instruction, you have the help or everything with the documentation here. Again, it's very important. You have to clearly understand what the requirement, right? You have to clearly understand what the requirement of this program before going on with the planning and coding. So the more time and the more specific you work with it, understanding programming, the more success rate you can go with you can have with the program, right? Now you have the plan, the logic, the plan the step for program and what they include, and it might include the algorithm into the program. Algorithm is a sequence of steps or rule you follow to solve program. Most common planning tool is the flowchart. It can be the pseudocode. Also in the planning, also you have the data checking. You have to list down all of the testing scenario you want to test to make sure after you done the program is deliver what you expected here. So I think again you have a very short video here where I have about the algorithm. What's the algorithm?
If you're a college student like me, especially, you need Grammarly in your life. Grammarly is a digital writing assistant.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm does twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all, since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2. But then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that, it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
Okay, so let's understand that the algorithm is a sequence step or rule you follow it when you solve problem, right? So we can develop it by the whole, or you have the sum of the available online. It's up to you. You have the code program, you have the 100 of programming language available. It's choose based on the feature, and basically they are quite similar in their basic capability here. Coding actually easier than the planning step. So basically for the life cycle here, the understanding problem and planning are the most important step in the case, right? So when you work with the planning, you find out what is the input, what's the output, and find out all of the testing scenario. So when you're done with this one, you just convert them into the coding. It's very simple when you understand the logic. It's very simple when you do the coding here. Okay. Using the software to translate the program into the machine language, you can have the translator program. You can have work with the high level or low level. You have the syntax error. That is when you work with the translate here. When you translate it, when you compile it into the executable program. So every time you run it, you just got input from user or from anywhere, and you run the program Okay, now in the testing scenario, you have to make sure you test for the logical error. That means the output is what you expected or not. Right? Also, you have the debugging is the process of finding and correcting program error. Whenever something going wrong, you have to chase down to find out where it is, and you are the one who correct it. Putting the program into the production is the process depend on the program purpose. May take several months. You have the conversion, the entire set of action or organization must take to switch over using the new program or set of program. Maintain program. Make change after the program is put into production. If you got any feedback, any comment, and from the user, from end user, you have to come back to correct it or update it here. Again, this is a cycle, development cycle, because at any time you can go back and you change it here and you update it. Now, using the pseudocode statement and flowchart symbol, that is step in the planning. Is a planning. And pseudocode is English like presentation of the logical step to take in the solve problem. And flowchart is a what is it? Okay, it's very hard for me to pronounce this one. Pictorial representation of the logical step to take in the solve problem here. So now it's a pseudocode here. Pseudocode again. Pseudocode is not the real programming language. It is only the simulation, and it's very helpful in the case you work with the planning step. Pseudocode represent a number. This one here, the pseudocode represent a number of doubling the problem. So basically, for every program, you have a start, a stop. And for this program here, you input, you got the number from end user. And after that, you just double it here. My answer equal to my number times 2. And again, you take it out by the output here. You see, even that, this is very simple program. It's very simple program, but you still have follow the rule here. You have 3 type operation. You got the input, you do the processing, and you got the output here. Right? And that is pseudocode. The second one you can work with the planning is the flowchart here. When you create the flowchart, it follow here. Whenever you got the input here, whenever you got the input here, it's a parallelogram here. Whenever you got its input here, and everything with the processing, you have the rectangle. Everything with the processing, you have the rectangle here in the flowchart. And the output also, output is a parallel program. And also you have start and stop. You just follow them by the flow line, and you have the terminal symbol for the start and stop here. So here you see on the screen on the right, I have the pseudocode. On the left, I have the flowchart here. So you see, when you understand the logic, you can convert this one into the Python, or you can convert this one into Python around the whatever. It's very simple here, right? So we think about this one here. Again, for this class, you have some of the assignment you work with the Python, but basically you just work in the sandbox, in the SandGate only. You do not have to install the Python on the computer. But again, if you really want to study about the Python, I strongly recommend you to install and download Python and install your computer. So in order to download and install the Python, it have many ways to do that. You go to you have to go to Python. Download. Yeah, you go to the python.org and download here. Now it depends. Can we work with Windows or Linux here? So for this one, we work with Windows, right? So we just download the Python here. And you can run it. So when you run it in Python, you can run with in the interpreted mode or compiling mode. So yeah, this one is the idle here. So that is the interface of the Python and the download of this one. It doesn't matter, right? So we think about I run the Python, I 10, I 20, now I have the 30 here. Very straightforward with the interpreter here, right? But in the case if you want to work with the compiling, you can work with the new file here, right? So you can write everything from this one. I have I equal to 10, I have y equal to 20, and so on. I print every node. So in that case, if you want to work with the compile, you just save the file, desktop. Okay, and now if you want to run it, if you want to run program, right? Run the program, you can open the file, you store it somewhere, set it here. And that program you can run here. So we do the same, right? It's totally up to you. We can do with the interpreter or compiling it up to you. But anyway, this for this class, it totally up to you. You want to practice with the Python or not. If you want to practice deeply with the Python, you can download it here. But normally for this class, everything you can do it in the sandbox, in the same game. You do not have to do separate it on the Python. So again, come back to the program here, right? You come back to the program here. Right? So see when you understand the logic of the flow chart or the pseudocode, it's very helpful for you to convert it into the real programming language. Think about this one. I work with the Python here. So normally for the Python, I work with a Visual Studio Code. It's very helpful for me to chase it down. Yeah, I will tell you. Of course, I will check you everything without the side. So this one I work with pseudocode here. So when I can run it from here, oh, the thing is that one. I do not have anything with the from. So I have 10 and well, I print out the number is 10 here. Now come back with the slide again. It's very straightforward when you understand the logic from the flowchart and understand the logic from the pseudocode. You can convert it into the Raptor or Python or whatever it is. So this one is Raptor also, right? This is very simple here. You got the number, you just time it by 2, and you print it out what is the answer. Now, when you work with a pseudocode, again, when you work with pseudocode, you have something you have to keep in mind. So basically, you see, this is a two program. This is two program here. On the left, also you got my number, time it by 2, right? Also on this one, also we have got the number from end user and time it by 2 and print it out. The only difference between the two programs here is the prompt. It's a prompt here. So what is the prompt? Prompt is optional. Remember, the prompt is only optional, right? It is optional, but it's very helpful. It's a way to tell you what is going on and what you need from program here, right? So see, if you come back to my program here, if you come back to my previous program here, if I do not have a prompt, what happened here? If I do not have program, what happened here? I do not know what's going on with this one, right? I do not know what's going on with this one here. I know for sure when I enter the number 10, when I enter the number 10, it print out number 10 here. But if you think about if you are the end user, you have no idea what's going on. You have no idea what's going on here. So in whatever program here, try to include meaningful prompt to make it more sense to the end user. Right? So think about this one. You can come back to this two program here. The output is exactly the same. If you enter the number 10, the output is 20 here. Right? Do the same. But you see, for this program here, instead of get the input my number here, I got the prompt. I tell the user that enter a number. Make more sense. Right? And again, for the output here, I just print out my answer here. Now I take the print out here. My answer is my answer here. Make more sense for that. So keep it in mind whenever you do the programming. Try to integrate the prompt and make it meaningful and helpful to the end user. Okay. Okay, so we have some of the definition about repeating instruction. Okay, in the program here, right? In the program here, it only work for one number. Right? So think about if you want to do it for 10,000 number, what you have to do? You have to do it for 10,000 times here. One again, right? So think about this one here. You modify this program here. You input the number, my answer number 2. Again, you got you have the output, and again you have my number, new number. For every time you do it again and again, 10,000 times. It's not what it work with program, right? So instead of the program here, instead of doing on the sequence here, you have to work with the loop. So what is the loop? The loop is a kind of repetition. It's a series of the step. Keep doing it again and again. Repeat it here. You see, it's a repetition, right? It's keep doing it again here. And whenever you work with the loop, try to avoid an infinite loop. That means you run it forever, right? So think about this one here. Think about this program. Think about this Raptor program here. This is an example that when we work with a program. This example when we work the Raptor here, right? When I run program, you see, I have no prompt here. So from the end user point of view, he have no idea what's going on, right? So we should remember that you have to include the prompt here to tell user that enter the number here. Okay. Now I run it again. I enter the number 10 here. Right? So the output is 20 here. Again, it not really makes sense. So I can modify it here. The double is making more sense. So we have number 10 and enter the double is 20 here, right? Now see, if I want to do it for 10,000, or think about 10 times to make it simple, 10 times here. Of course, I can do it for 10 times, right? I can do it again 1 time. I do it 2 times. I do it 3 times here. Now make it simple, 3 times here, right? So I can run it here. The first one, I have entered number 10. The second one, number 20. And the third one, number 30 here. So the output, it works, right? It works here. But think about this one. If you want to do it for 10 times or 100 times or 1,000 times, you have a lot of work with this one, right? So instead of that, you have to think about using the loop, repetition here. Right? So whenever you do the repetition, remember that you only need a condition. The condition here is to tell you how you exit the loop. Otherwise, keep doing it forever. Right? So think about this one here. In order to think about if I want to do it for 10 times, right? I want to do it for 10 times for this one here. I maintain a loop. So when you work with the Raptor, you have the option for the loop here. See, you have the option for the loop. I drag it to the loop and drag it to the loop here. Now, when you look on the loop, you only have the condition here. Whatever it is, the loop only have the condition to check. In the Raptor, if the yes, you exit the program. If no, we keep doing it. But you think about this one here. It's very, very important thing you have to keep in mind here. So whenever in the Raptor, the condition true, you exit the loop. But in the real programming language, right, the condition true, you keep doing the loop. Is that the difference between the Raptor and the Python or whatever? That's why when you convert from the pseudocode to the Raptor, or when you convert from the pseudocode to the Python, you have to understand the difference between the Raptor and the Python, right? So think about this one here. I want to do it for 10 times, right? So in order to do that, I need a counter to count 1, 2, 3, 4, 5, 6, 7, or 10 here, right? So that's when I need to initialize the counter here. I do the count. I do the count as one at the beginning here, right? So yeah, I copy everything I put it here. And the condition here, you want to do it for 10 times, right? So whenever count here greater than 10, I exit the loop. Greater than 10. Now see, if I starting from the count number 1 here, you go to the loop, you check if the count greater than 10 or not, right? So at the beginning it's 1, not print it out. Do it again, do it again. But what happens in this program? What do you think? What going? Yes.
The loop will be infinite.
Definite, right? The definite is that thing here. The definite is because the thing is that in this one, you set the count number 1 here, right? And you check the condition here, count number 1, it never greater than number 10, right? So see, it keep doing again, check again, check again. Every time you check it again, always not here. That's why it's running again and again forever, infinite loop here, indefinite loop here, right? So how we correct it? What do you think? How we correct this program in order to run it, to stop it to 10 times here? Now let me run it here. Let me run program here, right? You see. And then number 10. 30 here. Very good. I think should and my compile. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110. Going forever. It's going forever. Okay, so now how can you correct it? What do you think?
Add a thing to add 1 to the count variable.
Yeah, right. Yeah. So basically for the loop here, you have something to do with the count, with the definite loop here. You have initialized the count. You have the condition to check whatever you want to exit. And the third step, you always have the action to change the counter. Otherwise, keep doing the same, right? And keep doing it forever. So for this one here, you want to do it 1 time, 2 times, 3 times, and 10 times. For each of the iteration here, you need to make sure that the count here increases by 1. Right? So now you can do it by, right here. So for every time, the new count equals the old count plus 1. So you can run it again. Right? So I have 1, and 2, and 3, and 4, 5, 6, 7, 8, 9, 10. Okay. I see it keep doing it, right? So we can change it down here. You can change it down for this program. Right? You see, you can change it down for this program. For at the beginning, you have 1 here, right? Now, 1 greater than 10 or not? No, right? Do it for 1 time. Now see, after the first iteration, you increase the count by 1. Right? So the second one you have 2, the third one you have 3, the 4, 5, 6, 7, 8, 9, 10, and whenever go to the 11, you exit it here. Huh? Okay. Do you have any questions so far? Let me know. Hello? For many of you online, you have any questions so far? Okay. I think you should take a short break, 5 minutes, and come back. Okay. Okay, let me resume. So that is a very simple example when you work with the loop, and this program is that you work with specified number of iteration, right? So think about this program here with the loop. You know for sure you want to run it 10 times. It's 10 times. That's why you have the specific number of iteration here. So basically, when you work with the loop with specified number of iteration, you have initialize the counter before the loop. Remember that you have to before the loop, right? You have to every iteration here, you have to test the condition, right? And inside here, for each iteration of the loop, you have to change the value of the counter, right? So we see you follow the rule. You have follow the rule here. You follow the rule with this one here. You can see what is it. You initialize. You see, you initialize the counter here. See, initialize the counter before the loop. That's why you set the count number 1 here, right? And for each iteration of the loop, you have to check the condition here. Check the condition, it's true or not, right? If not, keep doing it here, right? And for each iteration of the loop, you have to change the value of the counter. That's why you see you have to change it here, right? You have to increase by 1 here, otherwise you increase it indefinite loop. It could run it forever. Now that is the one type of the loop. The other one is that the other one is a loop with an unspecified number of iteration. So what is a loop with unspecified number of iterations? That means you can run it 2 times, 3 times, or whatever one, right? So we can make it changeable by every time you execute. So one time you can run it for 2 iterations, or the other time you can run it for 10 iterations, whatever it is. So in order to do that, in order to do the loop with unspecified number of iterations, again you have to test the condition, right? And you can work with the dummy value, or you work with sentinel value here. So basically, the sentinel value is the value you want to terminate it. So basically, the sentinel value is a value you can think about. It never ever happen in the real life. And in the summer programming, we can have the end of life file here. If you read the file, you read everything from the first line to the end of the to the last line in the file. You have the end of file here. Now think about this one. If you go back to this program, this program here. So this program is for sure you want to run it 10 times. Right? This one is the number of iterations is specified now. Now I can modify this program. I do not use the count here anymore, but I change it here. I change it this one. Zero like. So every time I check the condition, if number zero, I activate it. Okay, so if you look at this program, the program here run it forever until I enter the number 0. Right? So we think about it. I run this program here. I run this program. I execute run compile here. So we think about I enter number 1, number 2, number 3. Now if I want to terminate it, I put the 0. I exit program here. Right? So you are the one who control how to exit program here. This one it depends on you, right? So one time it can execute for 2 iterations, or 3 iterations, or 5 iterations. It totally is up to you, right? And the value 0 here, it is a value 0 here. It is the value to control how to exit the loop here. Make sense? Okay. Again, if this program here, you do not have the step to change to get the new number, it run it forever. Right? It run it forever. Okay, so I think it should be the last. Understanding about programming and user environment. Understanding the programming environment, basically for every program, you can work with the text editor. If you understand the syntax, you understand its syntax, you can work with the text editor here. But it should be better. It should be better. You work with the integrated development environment. So in that one, when you work with IDE here, they provide the editor, compiler and other program too. I think about the Microsoft Visual Studio. It's very helpful. So it tell you why. It tell you even that before you compiling, it tell you something wrong with the program. Right? It tell you something wrong with the program. Think about this one here. When I run with the program here again, right? When I run this program again with the Python, with the Visual Studio here, if I change this one, see, even that tell me something wrong with this one, right? Because the variable is not consistent, right? So you see, the first one is my number. I got it from end user, but you see, my answer is my number here. It's not consistent. It means that it tell me something wrong, even that before I compile it. Right? So it's very helpful. So basically, this program you totally can work with the text editor. I see you can work with text editor here. So you use the same. I just copy it here. I work with a notepad here. Notepad here. I paste it here, right? And I save it. I save it. Save it number. And this one I want to work with the Python. That's why I put the py here. Okay, so I save it. I save it the .py. Now I can run program. I can run my program. I can open it here. I can run my program from desktop. This one here. I do the same. Do the same. When I run it here, I use the number 10 here. So basically, you have many ways to write the program. You can use the text editor, but it should be better you work in the IDE here. IDE is an integrated development environment. Is that they have the compiler integrator, and even that it tells you something wrong even before you compile it. So in this class, I use both the drafter and the Python with the Visual Studio Code, and I have slide for what? Yes, I think that is the last slide. It instructs you how to work with the Python IDEO and the Visual Studio Code. It's up to you. Again, the Python is optional. You can download it or install it. Totally optional, right? You can work with the Python assignment in this class by working with the sandbox in the sandbox. You do not have to work with the Python IDEO or Visual Studio Code. But anyway, if you want to study more about the Python, if you want to work out more about the Python, you can download it and install on your computer. So here's a link to download it. And for the Python also, they already have the interactive mode that you see. The interactive mode with the Python. Yeah, from here you can work with the Python directly in the interactive mode, or you can work with the compiling mode. You can work with the link file here. You can write the code from here, or you can work with the Visual Studio Code. That's what I normally work with with the Python. So you download the Visual Studio .com. It's free, and after that you have to install the extension for the Python. And if you want more information, you can click the link here how to run the Python in the Visual Studio Code on the Windows. Yeah, for this class, I use both the drafter and the Python. You see some of this one here, some of my simulation I work with this one I work with the Python, right? But this one I work with the drafter here. This one I work with the drafter. What is your specific question? What? Do what? You want to do a Python or what? Hello? No. You cannot use the Raptor on Visual Studio Code. They are separate. You cannot use it. So you can use a Raptor separately and the Python on Visual Studio Code. But you cannot run Raptor on Visual Studio Code. Okay, so now understanding is the evolution of a programming model. So basically, the programming we break it down into procedural programming and object-oriented programming. So basically, when we work with the procedural programming, we break it down into function, and whenever we want to use it, it's call the function. Right? You define the function one time and you call it again and again. And in object-oriented programming, it's code on object and the thing, and for each of the object, you may have the method and you have attribute related to the object here. I think this video is very straightforward to have understanding between the procedural programming and object programming.
Pampers Cruisers 360. Live wild and free with up to 100% leak-free fit.
Hello, your translation device works.
We need to hire, order supplies, control spend.
Try Amazon Business.
A popular interview question concerns the 4 core concepts in object-oriented programming. These concepts are encapsulation, abstraction, inheritance, and polymorphism. Let's look at each of these concepts. Before object-oriented programming, we had procedural programming that divided a program into a set of functions. So we have data stored in a bunch of variables and functions that operate on the data. This style of programming is very simple and straightforward. Often it's what you will learn as part of your first programming subject at a university. But as your programs grow, you will end up with a bunch of functions that are all over the place. You might find yourself copying and pasting lines of code over and over. You make a change to one function and then several other functions break. That's what we call spaghetti code. There is so much interdependency between all these functions, it becomes problematic. Object-oriented programming came to solve this problem. In object-oriented programming, we combine a group of related variables and functions into a unit. We call that unit an object. We refer to these variables as properties and the functions as methods. Here's an example. Think of a car. A car is an object with properties such as make, model, and color, and methods like start, stop, and move. Now you might say, but Mosh, we don't have cars in our programs. Give me a real programming example. Okay, think of the local storage object in your browsers. Every browser has a local storage object that allows you to store data locally. This local storage object has a property like length, which returns the number of objects in the storage, and methods like setItem and removeItem. So in object-oriented programming, we group related variables and functions that operate on them into objects. And this is what we call encapsulation. Let me show you an example of this in action. So here we have 3 variables: base salary, overtime, and rate. Below these, we have a function to calculate the wage for an employee. We refer to this kind of implementation as procedural. So we have variables on one side and functions on the other side. They are decoupled. Now let's take a look at the object-oriented way to solve this problem. We can have an employee object with 3 properties: base salary, overtime, and rate, and a method called getWage. Now why is this better? Well, first of all, look at the getWage function. This function has no parameters. In contrast, in a procedural example, our getWage function has 3 parameters. The reason in this implementation we don't have any parameters is because all these parameters are actually modeled as properties of this object. All these properties and the getWage function, they're highly related, so they're part of one unit. So one of the symptoms of procedural code is functions with so many parameters. When you write code in an object-oriented way, your functions end up having fewer and fewer parameters. As Uncle Bob says, the best functions are those with no parameters. The fewer the number of parameters, the easier it is to use and maintain that function. So that's encapsulation. Now let's look at abstraction. Think of a DVD player as an object. This DVD player has a complex logic board on the inside and a few buttons on the outside that you interact with. You simply press the play button and you don't care what happens on the inside. All that complexity is hidden from you. This is abstraction in practice. We can use the same technique in our objects. So we can hide some of the properties and methods from the outside, and this gives us a couple of benefits. First is that we'll make the interface of those objects simpler. Using and understanding an object with a few properties and methods is easier than an object with several properties and methods. The second benefit is that it helps us reduce the impact of change. Let's imagine that tomorrow we change these inner or private methods. None of these changes will leak to the outside because we don't have any code that touches these methods outside of their containing object. We may delete a method or change its parameters, but none of these changes will impact the rest of the application's code. So, with abstraction, we reduce the impact of change. Now, the third core concept in object-oriented programming, inheritance. Inheritance is a mechanism that allows you to eliminate redundant code. Here's an example. Think of HTML elements like text boxes, drop-down lists, checkboxes, and so on. All these elements have a few things in common. They should have properties like hidden and inner HTML and methods like click and focus. Instead of redefining all these properties and methods for every type of HTML element, we can define them once in a generic object, call it HTML element, and have other objects inherit these properties and methods. So inheritance helps us eliminate redundant code. And finally, polymorphism. Poly means many, morph means form. So polymorphism means many forms. In object-oriented programming, polymorphism is a technique that allows you to get rid of long if and else or switch and case statements. So back to our HTML elements example, all these objects should have the ability to be rendered on a page. But the way each element is rendered is different from the others. If we want to render multiple HTML elements in a procedural way, our code would probably look like this. But with object orientation, we can implement a render method in each of these objects, and the render method will behave differently depending on the type of the object we are referencing. So we can get rid of this nasty switch and case and use one line of code like this. You will see that later in the course. So here are the benefits of object-oriented programming. Using encapsulation, we group related variables and functions together, and this way we can reduce complexity. Now we can reuse these objects in different parts of a program or in different programs. With abstraction, we hide the details and the complexity and show only the essentials. This technique reduces complexity and also isolates the impact of changes in the code. With inheritance, we can eliminate redundant code, and with polymorphism, we can refactor ugly switch case statements.
Yeah, so I think it's a very good video, and I will again I have the link in the slide, and if you want to know more about that, you can, let's see, go back to this one. Okay, so basically we've done everything with the lecture. We had some of the definition about hardware and software, okay, logic, logical error, syntax error, flowchart, and pseudocode, avoid infinite loop, right? And using text editor or ED to enter program statement. Now, for this class, we work a lot with the pseudocode, and you see some of assignment you have to work with the pseudocode, right? It's everything about where to go to the class here. Go with the scroll it down, break it down in the 8 module, right? You see, for each module, you have assignment with the debugging exercise. That is, you are supposed to do with the pseudocode and flowchart. That's why you need to understand about the logic of the pseudocode and the logic of the flowchart here. Now, in the pseudocode, again, pseudocode is artificial and informal language that help programmers to develop an algorithm. So basically, very helpful during the planning step here. There are three basic elements in every program. The same when you work with the pseudocode, they are input, and you have the processing, and they are output here. So it's very simple program. It's a program that a shop owner will sell ball, and each of them is $5 here, right? And you have to write a program to ask user to ask the seller to enter how many ball he sell for one day, and from that you have to find out how much money you can get it here, right? So again, for every program, you have to find out. You have the processing with the 3 steps here. You need the input, right? You do the processing and the output here. So it's very simple program. You get how many balls, right? Use each of them is the time by 5, and after that you just print it down revenue here. Right? So here is that's what you work with the pseudocode. You see, you have start and stop. Every program has start and stop. Right? Now, the first step in this program, you have to find out. You have to think about how many variables you need to use for this one. Right? So in order to that, for this one, you know that you need 2 variables. How many balls? Right? So from the ball, you find out what's the revenue here. Right? So for the first step here, you have to do with the declaration. Declaration that the ball here in the num here that in the number format. Num here that in the number format. Num that in the number format. Right? And the revenue here is the number format. And later on, we know that you have some of the string format and character format. Whatever. Later on, right? Input ball that means you get the number of balls from the end user. Right? And from that, you find out is the revenue is a ball times 5, and after that, you just print it out the revenue here. So again, you have input, you have processing, and you have the output here. Right? So you can follow it with the Raptor here, but actually the Raptor is quite the same with the flowchart. You can see it here, right? It's quite see. You have the input here, input everything in the parallelogram here, and the output everything in the parallelogram, and processing is the rectangle here. So you see, the Raptor is exactly quite the same with the flowchart. Okay, so this program we see it's very simple, and you can convert it into the Raptor, or you can convert it into the Python. It's very simple. But again, for any program, again, my view is that always try to integrate the prompt, right? Always try to include the meaningful prompt to tell our user what's going on here, right? So see, when you compare with this one, you have no prompt here. But when you compare this program, you see you have the prompt to tell user enter number of balls sold for today, and for the output also revenue for the today. Right? It makes more sense if you are the end user. Now think about this one. This is very simple program here. Now we have new problem. The problem number 1. Now the shop owner want to change the price for each of the ball from the 5 to 6. So what do you have to modify program? What do you think? If you look on this program, if you want to change the price for each of the ball from 5 to 6, what do you have to change here? Yes?
I'd have to change the ball times 5.
Yeah, right. So it's very simple modification here. You change it from the 5 to 6. Right? Now later on he call him. 6 is not much money. You want to change it to 7 or 8 or 9 or 10. So every time he want to change, he have to call you. You are the programmer. You have to come to the store and change program here. So what it make more? It make more efficient for this program. What do you think? Yes.
Variable.
Yes. You need one more variable, right? You need one variable price, and you allow the user to enter the price here by himself. So you do not have to come back and forth every time to change it here, right? So for this program, I have another problem. Here's another problem. It's number 2 here, right? The shop owner want to have the option to enter the price for each the ball to himself, so he able to change the price by himself whatever he want. So we see instead of using now, you have 2 inputs, not only 1 input anymore, right? You need input for how many balls, and you need input for the price of each of the ball here, right? So see, instead of declare for only the 2 variable, now you have to declare for 3 variable here: number of ball, number of price, and number of revenue here, right? And see, this is the prompt. You got it for the ball. This is the prompt. You get it for the price, and you file it down by the processing, and you do the output here. Okay. Again, this okay, when you understand this one, you can convert it into the Python or Raptor, whatever you want. So now, but whenever you work with a Python or whatever it is, or pseudocode, you have to pay attention to the error. And remember that normally you have two type error here. You have logical error and you have the syntax error, right? Syntax error is program is not work until you have to find out and fix it, right? And for example, you have the program here. You got the three input. You got the three input from you got the ball from the user here, right? And you store it in the variable name. And now we have revenue time ball time file here, but you got the syntax error for this one, right? Because the name is inconsistent here. You see, when the program compile to this one here, right? It calling down what is the ball here? What is the ball? You have no idea what's the ball. That's why you have the syntax error for this one, right? So remember that syntax error if the program is not work until you have to find out and fix it. And the most common one is inconsistent in variable name. And that is what you expect to do in the pseudocode, in the debugging exercise. You have to find out to make sure that every variable they must be in the consistent. And the second one, the second type error is the logic error. Program run it, work it, but the output is not what you expected here. It's the same, right? The same is this one here. Now instead of timing the file, you plug the file. That is the logic error. Program run it, but the output is not what you expected here. And again, in your debugging exercise, you also have some of the steps. You have to find out what is a logical error in your program. Okay. Again, pseudocode is not the real programming language. It's only the artificial and informal language. But it's very helpful in the case you work with the planning step here. And once you understand the logic of pseudocode or flowchart, you can convert it into the real programming language here. You see, if you convert it program here, if you convert it program from the pseudo to the Python here, it's very simple because you understand the logic here. So I think that's all for today. And yeah, so basically the Raptor and also work with you on the Raptor already. It's a Raptor, so that also it ran. Yeah, I already include in the slide. So if you need more information, you can read it from the slide here. So what else? Yeah, Raptor is the same. Raptor is the same. Okay, so for this class, we also work something with the Python. Also, right? That's why I also include some of the slides into the lecture here. But anyway, I think it should be better. We work on Thursday. Right? So basically, on Thursday I will come over to the Python with the very basic thing you need to do with the homework on the module 1, and so I have you to work with the debugging exercise, Raptor program and Python program. Okay, so normally the way I work is that normally I finish every on the lecture on Tuesday, and on Thursday I reserve you to work with the homework assignment. I can help you with the homework assignment. Okay, any question? Hello, any questions so far? Okay, so if no question, let me check the attendance. Sometimes I forgot it, so in any way, if I forgot it, just remind me. John, are you here? Erica, are you here? Erica? Elizabeth?
Here.
Okay. Leyland, are you here? Leyland, are you here? content right here. Anyway, if I pronounce your name wrong, please correct me. If I wrongly pronounce your name. Content right here. Eric, are you here?
Here.
Eric here. Joseph, are you here? No. Okay. Devin, are you here? Devin, are you here? Lindsay, are you here?
Here.
Okay. Mika, are you here? Mika, how to pronounce this?
Mika Laundry?
Okay. Very hard for me.
Here, it's Michael.
Oh, Michael, okay. Okay. Matthew, are you here? Okay. Mallory, are you here? William, are you here?
I'm here.
Okay. Nathan, are you here? Nathan, are you here? Hunter, are you here?
Yeah.
Are you Hunter? Okay. Jared, are you here? Start. Are you here? No. Marcus, are you here already? Right? John, are you here? John again.
I'm here.
Are you here?
I'm here.
Ademola, you here? Adon, are you here? Daniel, are you here?
Sorry, Ademola is here. Ademola is here. Ademola is here.
Okay. Daniel, are you here? Parker, are you here?
Here.
Carl, are you here? Carl, are you here?
Ademola is here. Yeah, thank you.
Carl, are you here? Otis, are you here? Alexander,
I'm here.
who are you?
Otis.
Okay. Alexander, are you here?
Here.
Drew, are you here?
Here.
I'm here as well. I don't know if you heard me. Carl.
Or
Yeah, I hit the space bar. I don't know why it didn't
okay.
go through.
Tucker, are you here?
Yeah.
Okay. Luke, are you here?
Not here.
Okay. Marco, are you here? Marco? No. Okay, so I see you guys on Thursday. Okay, and remember, anytime, any question, you can inbox me or send me the email, or you can join me in my office hour. Okay, anytime.
Malcolm did say he was here, by the way. He did an emote reaction.
And I will upload the recording video on the announcement for you to either you want to watch it again.